In our pre-calc unit, we're going to talk about some quadratic factoring. So first off, your front page has all of your curricular outcome and all the different indicators. Now, the biggest distinction, outcome is your overall goal of what you're going to be learning in pre-calc 20, whereas indicators are just some methods of doing that. I try my best to try and fill in every single part because that should potentially give you more of an understanding of the outcome, but that's not necessarily the case the entire time. There may be times that if there's 20 different indicators, I may only need to consider 5 for you to have a good, proper understanding of the outcome. Now that's my little rant on the curriculum. We're going to be using Rubrics, which will be a self-assessment tool for you. So at the end of this unit, if you can fully factor composite functions without any error and write all answers in simplified form, you have mastered. You are good. But if you can only factor multi-step expressions, and you can demonstrate the process of factoring, then you would only be considered proficient. If you can demonstrate the process of factoring with single-step expressions, well, you're more on the approaching side, and that means that you'll have to put in some more effort and some more work time, as well as ask more questions. Whereas if you're becoming more consistent with criteria, that means that you're going to have a lot more time. At the bottom is a timeline. Please pay attention to that. So first things first, we're going to go back to grade 9. Now, I'm referring back to my grade 9, but at the same time, we had also done this in Foundations Pre-Calculus 10. So first things first, I want to see what you actually remember. In order to properly expand these, this should take probably no more than 3 or 4 minutes for someone who's at least relatively okay. If it takes you anything longer than 10 minutes to factor these out, or not factor, expand these out, then you're going to have a lot more trouble and you're going to have to practice more. Of course, at any point in time, if you need to pause a video because you need to have a little more time to work on something, to copy something down, please do so. If you just need to rewind at any point in time, please do that as well. First off, I'm going to help expand these. FYI, if you are looking at extra supplemental stuff and you see this, put a big X through it and never use it, please. All right, I'll have explained this in other courses, but the overall idea is this only works for a binomial by a binomial. It will not work for anything that potentially has more than 2 terms. How to properly expand, what you will need to do is you will need to take every single term in one polynomial and multiply it by every single term in another polynomial, which means I'm going to have to take my x and multiply by x. By exponent loss in grade 9, we had learned that x multiplied by x is an x squared. And x multiplied by a positive 3 gives us a positive 3x. Negative 4 multiplied by x. So I'm just drawing arrows to help us illustrate. It would be negative 4x. And negative 4 multiplied by a positive 3 is a negative 12. To finish off this question, we would then combine any like terms. We'll see that these 2 terms are like. We would then write x squared, subtracting the 1x, because of 3x, subtracting 4x's, will give us a negative 1x. The 1 is irrelevant, you don't really need to write that. I'll put that there anyways. It's not wrong to write it. It is up to you. And finally, writing negative 12. Next one, we'll be able to go a little bit faster because 5x, which is on the outside, will get distributed on the inside. So 5x by 2x will be a 10x squared. 5x by negative 5 is a negative 25x. Now I'm just going to make that actually look like a 5. So that takes care of the 5x. On the next part, we see that the entire term in front of this set of brackets is a negative 3x, which means we are going to be taking a negative 3x and distributing it inside that set of brackets, which means negative 3x times positive 1 is a negative 3x. Negative 3x multiplied by negative x will be a positive 3x squared. And just like in the last one, we combine our like terms. In this one, though, we have things that are the same and things that are the same. Now, even though I have this in yellow, I'm going to put it in black because seeing yellow on screen is really difficult. But 10x squareds adding 3x squareds does gives us 13x squareds. Negative 25x subtracting 3x is a negative 28x. And there's those two. The next two, let's go even a little bit faster. 3x gets distributed onto each of those terms. I don't necessarily need to write the arrows because I can do quick multiplication in my head. 3x by 2x is 6x squared. 3x by positive 1 is 3x. It does not hurt to draw the arrows. But if you focus on drawing those arrows, and that's all that you are focusing on doing and not completing your work, then we're going to need to find some better priorities. A negative 7 multiplied by 2x is a negative 14x, and negative 7 by 1 is negative 7. Again, combine like terms, the 3x and the negative 14x. Always want to try and write things in descending order, which means that we write with the highest power first, so that x squared at 3x subtracting 14x does give us a negative 11x, and finally we have a negative 7. Our next one is 2x subtract 3 squared, which means it is 2x subtract 3 multiplied by 2x subtract 3. It does not mean that you just take 2x squared, which would be a 4x squared, and negative 3 squared is positive 9. It also doesn't equal 4x squared subtract 9 because you square the 3. It does not equal those. This is what it equals, which means this is a thing that we need to properly distribute. Again, I'm just drawing the arrows for demonstration and illustrative purposes. We can properly do our work otherwise. 2x by 2x is 4x squared. 2x by negative 3 is a negative 6x. Negative 3 by 2x is another negative 6x. And negative 3 by negative 3 is a positive 9. You'll notice with our final work that it does look similar to one of these, but it's not exact because we have that 4x squared, a negative 6x, and a negative 6x gives us a negative 12x, and we add the 9, and there we go. This is not the same as this. Subtracting 12x makes it so much different than that. Final example, no arrows, 2x by 2x, 4x squared, 2x by positive 7 is a positive 14x, negative 7 by 2x is a negative 14x, and a negative 7 by a positive 7 is a negative 49. Combine the like terms, and you'll notice that 14x and a negative 14x gives us 0x's. It is technically still fine to write it as add 0x's, but it would be improper. It's not common practice to write a 0x, which means the simplified version would be a 4x squared. Oh, sorry. subtracting 49. And there we go. So that's kind of our bit of review of grade 9 and the first thing that we do in Foundations 10. Now we're going to get into what we're going to have to relearn and remember from Foundations Pre-Calculus 10. And that is we're going to talk about factoring. The first and easiest way of factoring is always our greatest common factor. Or, in abbreviated terms, the GCF. A GCF is simply what number will go into all of your terms. Now, it's not restricted to just numbers. We also talk about variables. So I'll show you the kind of the easiest way to do it first, and then we're going to get into more common ways of writing it. So factoring is essentially a form of division, which means we're going to have to divide both of these terms by the same thing to factor. You'll notice in a 2x and a 6, both of them can be divided by 2. But here's where factoring and division change or differ. You are not actually dividing 2x by 2 and being left with just x. Same time as you're not just dividing -6 by 2, getting -3, and being left with that. Factoring means when you factor something, you have to put that common factor out in front. And that's it. You don't necessarily need to write that division, which means we don't need to write that. You can just look and say, okay, I divide that by 2. I put my 2 out in front. I write my x, write my subtract 3, and we're all good. In our next one, I can divide them both by a 3 and by an x. So if I'm going to divide them both by 3x, I just write my 3x out in front. 3x squared divided by 3x would be x. -9x divided by 3 would be -3. Yes, this is completely coincidence that those are the same. But our answer is fully done. For me, I don't even necessarily require you to write down what your greatest common factor, because in this one, it's 7. By simply writing your greatest common factor there, you're set. 14x squared divided by 7 is 2x squared. -49x divided by 7, -7x. +56 divided by 7, +8. There we go. And we're done. That's it. After this step, we need to take a look at what type of polynomials we actually have. If we've already taken out our GCF and we have a binomial, so binomial meaning 2 terms, we have 2 options. It is either a difference of squares, which is really easy to factor, or it is prime. Now, when I do talk about 2 options, I do have to clarify that I am strictly talking about pre-calc 20. Those of you that go on to calculus, you'll see that there are other options when you have 2 terms and you've already factored out your GCF. For example, you could have sums or differences of cubes, but that's done in calculus 30. So if you have a difference of squares, well, let's look at what the key terms are in there. Difference and squares. Well, difference means subtraction. A square means it would have to be a perfect square. If we look into this question, we see that yes, there is indeed a difference. We are taking an x squared and we are subtracting 36. So it's a difference. A square means, well, is this a perfect square? And is this a perfect square? X squared absolutely is, because it's x times x. 36 is also a perfect square because it's 6 times 6. In order to properly factor a difference of square, it is extremely super simple. You make two sets of brackets. You take the square root of that first term, so square root of x squared. Here, put that as a side note. The square root of x squared is x. We're going to put that in the first spot of each of these brackets. Then we're going to take the square root of 36. Now we'll talk about this a little bit more carefully. It is 6. More specifically, it's positive and negative 6. Again, we'll talk about that a little bit later on as well. So depending on how you do it, either you can treat it as a positive, negative, but either way, you put the 6 into the second spot, make one positive, one negative, and this is factored. Before we get too much farther, we're going to talk about what is the connection between factoring and checking our work. Well, in order to check our work, all we have to do is distribute this out. So if we want to check our work, x times x is x squared, x times negative 6 is negative 6x, 6 times x is a positive 6x, and 6 times negative 6 is a negative 36. A negative 6 and a negative 6, well, that produces 0 x's. We only have x squared, subtract 36, and our question is done. We know that this entire thing has been factored correctly because when we expanded it back out, it gave us right back to our answer. Our next question is also tricky. Now, if you're going to start doing this the way that we just had done this one, you're not going to get into a perfectly simplified version. If we do go, here's what it's going to look like. We take the square root of 4x squared. Well, that's going to be 2x. We take the square root of 10, and, oh, sorry, not 10, 100. It would be 10. It would be positive and negative. So all we'd have to do is put the 2x into the first spot, 2x into the second spot, 10 there, 10 there, make one positive, one negative. It doesn't matter which one, but this answer is not simplified. It is not in its simplest form. The reason for it is because I can still take a 2 out of that term and that term. I can still take a 2 out of that term and that term. Because there's still a common factor in each, it just has to be one. But if I can still take a common factor out of either one of these brackets, it's not fully simplified. So let's go back to our notes. If we have taken out our GCF, 4x squared and 100, sorry, not 11, have a greatest common factor. That greatest common factor is 4. So when we factor a 4 out of 4x squared, we're left with x squared. We factor a 4 out of 100, we're left with negative 25. And the beautiful bit of information is an x squared and a 25 are still perfect squares. We can still do a difference of squares. The only difference is that that 4 has to come down. We still make two sets of brackets. We don't need to write all of this work because by grade 11, I hope that you know that the square root of x squared is x. I hope that you know that the square root of 25 is 5. And all you have to do as the last step is make one positive and one negative. So what's the relationship between this answer and this answer? Well, like I said, this entire set of brackets, you can factor a 2 out. So if we factor a 2 out, we would be left with an x plus 5. In this set of brackets, we'd have to factor another 2 out. When we factor that 2 out, we'd have an x subtract 5. But those two 2's that we have left, that would take out, becomes that 4. So I'm not saying you can't necessarily do this, but you do have to be cautious of the fact that it may not be fully simplified, which means that you have to make sure you know how to do your work. And in all this, taking out a greatest common factor is going to be a very great way to keeping your work down to a minimum, really. Alrighty, let's make these ones a little bit faster. Well, these ones are definitely not perfect squares. At the same time, I can factor a 9y out of both of these. Why do I know that? Because 7 plus 2 plus 9 is 18, which means it is divisible by 9. So when I factor out a 9, and there's a y here, I'd be left with 1 subtracting, and 729 divided by 9 works out to be 81 x to the power 4. Now that I've factored out my greatest common factor, I can look at this. Are these both squares? Yeah, 1 is 1 times 1. 81 is also a perfect square. It's 9 times 9. And x to the power 4 is actually x squared times x squared. The last thing we really need to look at is it a difference? Yeah, it's subtraction, so we're good. So 9y, I can make my two sets of brackets. 1 square root is 1. The square root of 81 is 9. Square root of x to the power 4 is x squared. Sorry, writing utensil is a little bit off. Make one positive, one negative. So just as a quick little note to myself, I'm actually going to switch these two for next year. Which means I'm actually going to go over to this example before I finish off this one. X squared, yes, is a perfect square. 4 is a perfect square. So we have a difference of squares, right? We have the squares. So we're all good for just going x plus 2, x minus 2. No. The difference is what makes it a difference of squares. This is not a difference. This is a sum. If you have a sum of squares, and we'll talk about what this actually means in one of our later units, one of our later units, we'll see this has no solutions. If you have a sum, all I have to do is say it's prime, and that's done. So now we can come back over to this one and see, well, I can't really factor anything with the 9y. That's fine. 1 plus 9x squared, well, just like we talked about here, we can't factor a sum of squares. So that one would literally be written out exactly as it is. This one, though, is another perfect square, and it's a difference, which means this one can be made into two more brackets. Square root of 1 is 1. The square root of 9x squared is 3x. We just have to make one positive and one negative. Again, this only works if you have a difference in between. We can't go any further because even though 1 still can be square rooted, 3x really shouldn't be. Our next method is, again, if you've taken out the GCF, I'm literally writing this as many times as possible to make sure that you remember this. And it is not a binomial. Again, that's exclusive to pre-calc 20, because we'll do more in calculus. It could either be a simple trinomial or it could be a complex trinomial. Obviously, simple trinomials are the easier one to factors. These trinomials have a very specific formula. Formula. That is definitely a nice typo. I'm sorry, not even formula. Just form. It's ax squared plus bx plus c, where the a equals 1. So, is this a simple trinomial? Have we taken out our GCF? Not yet. So let's take out our GCF. 2. We factor a 2 out of 2x squared, we're left with x squared. We factor a 2 out of 2x, we're left with negative x. Very specifically, negative 1x. I can put a 1 in front of there too. Again, I'm just going to do that for an illustrative purpose. You don't have to, but it's going to help also illustrate our next kind of bit of work. Subtract 6. That should be a nice rounded bracket. Our next bit of work, if we remember back to our calculus foundation pre-calculus 10, what we had done is we had found a product and a sum. A product of the a multiplied by the c, which means 1 times negative 6. Which is negative 6. Our sum is going to be our b value. In this case, negative 1. So what we need to do is we need to look for 2 numbers that give us a product of negative 6 and a sum of negative 1. Because we've done enough practice with our foundations 10, I'm just going to quickly go over the answers. Negative 3 and positive 2. Because negative 3 multiplied by multiplied, put the forms in there. Multiplied by a positive 2 gives us negative 6, and a negative 3 add a positive 2 gives us negative 1. With simple trinomials, it's really nice and easy. We make 2 sets of parentheses, and we literally just write x subtract 3, x add 2. Also, not forgetting that we did have that GCF. And that's fully factored. If we want to potentially check out our work, there's a few different ways. When we're multiplying, the first thing you need to know is you only distribute one thing at a time. You cannot do this. You cannot take the 2 and multiply by that second thing. That is a big no-no. No. 2x subtract 6 would then become this first thing. It would basically be putting the 2 in there. We literally write down that next term by itself. We distribute, once again, 2x onto an x is a 2x squared. Add a 4x, subtract a 6x, subtract a 12, and combine the like terms. 4x subtracting 6x is negative 2x, and subtract the 12. We're right back to our answer. So let's make these next ones nice and easy. We have no GCF. All we have to do is product and sum. This is all the work that you need to show. 1 times -16 is -16. Sum of -6. Two numbers that have a product of -16 and a sum of -6, -8 and +2. It does take work. It takes practice to get what these numbers are. And all we have to do is write x subtract 8 and x add 2. And we're done. Factor out a GCF, 2 x squared plus 5x, subtracting 24. So when we do our product and sum, instead of getting 96 and 10, we have -24 and 5. The numbers may not come to you right away. But once again, it takes practice. 8 and -3. More specifically, a +8 and -3. Write down our factor that we've taken out. X add 8. X subtract 3. Instead of us going all the way to +225, let's make our lives easier with factoring out that 3. 3x squared, subtract 10x, add 25. So product of the 1 times 25. That 3 is way out in front. We don't have to worry about that. Product of 25, sum of -10. The only numbers that is possible with are a -5 and a -5. You'll notice on each of these examples, I've written things completely horizontally. Sometimes I write it with the brackets. Either way is fine. The only thing with this one is it's actually can be even more simplified. It's not wrong to write it like this, but it's going to be good to get into the habit of writing it more simplified. Because x subtract 5 times x subtract 5 is x subtract 5 squared. And we're done. Those are simple trinomials. Again, they're simple. If we don't have a simple trinomial, we may have a complex trinomial. Obviously, complex means it's going to be more difficult. Now, these are in the form ax squared plus bx plus c, where the a value is not equal to 1. That is a very big difference from this one, where our a is equal to 1. This one is a 1. This one is a 1. Even though this one originally has a number other than 1 in it, well, as soon as we factor out that 2, we have a 1 in front of that x squared, which means that's simple. We're going to work with things that are complex. Last year, I gave you these steps. I'm just going to draw you. So we'll talk about what these steps are in the first one, and then we're going to just kind of commit it to memory. But in pre-calculus 20, we're going to work with complex trinomials enough that you're just going to have these steps completely ingrained into your mind. It's just going to be a process. I do not give these steps in any kind of exam. Use them to practice, commit them to memory. If you haven't practiced them enough last year, practice them enough this year. So first things first, find product of the leading coefficient and the constant term. Well, that's actually no different than what we've already been doing. 3 times by -4 is -12. Identify the coefficient in front of the x term. That's going to be our sum. Well, so what's different? Well, we haven't done anything different here. We're going to find numbers who have the same product as number 1 and same sum as number 2. So two numbers that are going to multiply to give us negative 12 and have a sum of negative 11 will be negative 12 and positive 1. Again, still nothing's different. But if you were to write this, you'd be wrong on so many levels. I wouldn't even be able to give you any marks for this. That's wrong. Here's what you do. You'll notice that these first 3 steps are very similar to simple trinomials. Well, what makes it different are these last 4 steps. What we're going to do is we're going to break that x term into the 2 numbers from the previous thing. So what that means is I'm going to literally take my negative 11x and turn it into a negative 12x and a positive 1x. Because if I were to take negative 12x and add 1x, I get negative 11. I'm just going to rewrite my 3x squared and my negative 4. Just so you know, it does not matter which one we put first. It does not matter. But our next step is we're going to split these 4 terms in half. Split them in half right after that x. It's going to make your life a little bit easier. Next step, find the GCF and factor from the first 2 terms and then the last 2 terms. That means from these 2 terms, I'm going to take out a 3x, which means I'm then going to be left with a x subtract 4. From these 2 terms, well, there's nothing really common. But what I can still do is I can factor out a positive 1, which means I'm left with an x subtract 4. This is what you need. You need this to be the exact same as this. So for you to do step 7, you need to factor that common factor from this first half and the second half. So I can factor my x subtract 4 out of this term. Well, what am I going to be left with? I'm going to be left with this 3x. If I factor in x subtract 4 from this entire term, I'm left with a positive 1. And this is this trinomial factor. It doesn't matter whether you write it this way or if you write it this way. Both are perfectly fine. It does take practice, and that's what we're going to do. I'm going to go through these next 3 a little bit faster. Just going to boot it up a little bit. But I'm still going to talk out my steps. 4 times 6 is 24. Sum of 11. 2 numbers that give me that product and sum would be a positive 8 and a positive 3, which means I'm going to take all my work, write a positive 8x and a positive 3x. It doesn't matter which one I write first. Bring down my 4x squared, bring down my 6. Cut or write in half. I can factor a 4x out of the first 2 terms and be left with an x add 2. From the next 2 terms, I can factor out a positive 3, again being left with an x plus 2. I can then factor an x plus 2 from both of those terms. I'd be left with a 4x from that first set, and I'd be left with that positive 3 in that second set. And that's all it is. I do require that you make sure that you do factor it out as a positive 3. That is going to save your life. Oh, there's even more. Sorry, I thought there was only 3. It means more practice. Product and sum. product of 60, sum of negative 17. This one might be trickier. So we're just going to have to do some work. You may think, okay, it's... Actually, I think I have this one as a specific reason. Yes, I do. There's two possible answers that some people may think. I could have 20 and 3. Well, meaning that I'd have to have negative 20 to get my negative 17 and a positive 3. But there is absolutely no way you can take negative 20 and multiply it by positive 3 to give us a positive 60 as a product. You may come across some situations where it looks like there's more than one answer. There is not. There is only one. The answer is a negative 12 and a negative 5. That is the only way that you can get a product of 60 and a sum of negative 17. Negative 12x, negative 5x, split her down the middle. Factor out that 2x, which is common. In this next one, if you factor out now hold off on just copying this right away. If you factor out a positive 5 factored out of a negative 5, you'd still be left with a negative x. Factoring a positive 5 out of 30, you would have a positive 6. You'll notice right away here that x subtract 6 and negative x plus 6 are not the same thing, which means we technically did not factor this correctly. What you do need to do is factor out a negative 5. That will allow us to be left with an x in that first spot and a negative x or negative 6 in that second spot. Now that we have the same factors, we are set for finishing our factoring. Next example, 12 and 6, 72, negative 72, sum of negative 1. Well, because the sum is negative 1, it means that the numbers actually have to be quite close. That's 9 and 8. Which one's positive, which one's negative? Well, it's negative 1, which means it's going to have to be a negative 9. Negative 9x, add an 8x, 12x squared, bring down that negative 6 too, split her down the middle. I can't factor a 12 out, but I can factor a 3 out. More specifically, I can factor a 3x out, leaving myself with a 4x. I'd be left with then a negative 3 here. The next two, I can only factor out a positive 2. Again, so that I can be left with a 4x subtract 3. I get my 4x subtract 3, be left with a 3x add 2. And our final example, product of 36, sum of 20, what possible numbers could we be dealing with? It would be a positive 18 and a positive 2. Last time I'm going to say, it takes practice. I'm just going to write this over a little bit, even though I am breaking down the 20, it's just so I have enough space in between the other work that I've already done. I can factor Well, I split her down. You can potentially just do that as a mental exercise. But 9x, be left with an x plus 2. I can factor out a 2. Still be left with an x add 2. Factor out that x add 2. I'm just going to make that 9 look a little bit nicer than it originally looked. And there you have it. We reviewed some factoring, or sorry, reviewed some expanding, reviewed greatest common factor, reviewed difference of squares, reviewed our simple trinomials, and reviewed how to do our complex trinomials. That means that you can go have some fun.